Those are the abbreviations for sine and cosine. Just like before, we're going to be using the same information. We're going to be using the acute angles. We're going to use the hypotenuse this time. Remember, that's this cute little thing across from the 90-degree angle. We're going to abbreviate that hype. I'm going to hype up the hypotenuse today because we're talking about sine and cosine. We have the opposite leg and the adjacent leg. And of course, as you know, that all depends on the angle that you're talking about. It depends on the angle. Make that a little smaller. It depends. Okay? So for this purpose, we're just going to go over the sine and the cosine of angle X to kind of get you some background. X, of course, is our angle that we're talking about. The sine of X is equal to the opposite over the hypotenuse. The opposite over the hypotenuse. And sometimes you'll see this written as so. So. This is to remind you that the sine of the angle is equal to the opposite over the hypotenuse. The cosine, on the other hand, is equal to not the opposite, but this time the adjacent side over the hypotenuse. All this is just overhyped. Wink, wink, nudge, nudge. That was a math joke. I hope you liked it. It's all overhyped. Hype. The abbreviation that you'll often see for cosine is ca. You know, like you park the car in the driveway. And that's, of course, to remind you that the cosine of any angle is equal to the adjacent side over the hypotenuse. So again, we have so, ka, and don't forget our fabulous friend tan, as in tangent. The tangent of x. He's still out there, but his abbreviation is TOA. So you'll see SOHCAHTOA. SOHCAHTOA. There's different mnemonic devices for all of them, but those are the ones you'll see. So if I were to write the sine of x, I would write the opposite side is YZ over the adjacent side. Just kidding, not the adjacent. Oh my goodness, I'm worried about the whole tangent thing. The hypotenuse, YX. The cosine of x is the adjacent side, XZ, over the hypotenuse, YX. Okay? The really important stuff is that you just kind of remember these. So, SOH, Ka, CAH, TOA, SOHCAHTOA. Say it. Bet you didn't say it. Did you say it? So ka, toa. All right. Moving on then. Like I said, these abbreviations will come in handy. They're little pyramid doodads. SOHCAHTOA, opposite over hypotenuse for sign. Take the time and write this down in your notebook. Pause if you need to. Adjacent over hypotenuse, and toa. Opposite hypotenuse. Opposite over hypotenuse. Sine and cosine are way overhyped. Cosine. Adjacent over the hypotenuse. Don't forget about your buddy tangent, because he's still hanging out over here. Okay. Our first example, again, this is going to just hang out right here. If it's off to the side, that's totally fine. So in this type of problem, we're asked to find the sine and cosine of the acute angles. So let's find the sine of x. Here's x. The sine. The sine is the opposite over hypotenuse. Now it takes a while, and use these diagrams. They're there to help you. The sine is opposite over hypotenuse. Okay, that's opposite. So the opposite side is 3, and the hypotenuse is 5. Okay, maybe with this red, we can label those sides as opposite and hypotenuse and adjacent. Opposite over hypotenuse. Opposite is 3. The hypotenuse is 5. Okay, so the sine of angle x is 3 over 5. The cosine of x is the adjacent over hypotenuse. The adjacent side to angle x is 4. The hypotenuse, again, is 5. All right. Using the blue, let's talk about those. Of course, this is the hypotenuse and will always be the hypotenuse because the hypotenuse is always across from the right angle. Right? Right. So that's the hypotenuse. Across from means opposite, so this is the opposite side to angle y. The adjacent side is angle 3. So let's do the sine of y. Okay, let's remember what the sine is. Sine. So, ka, toa. Okay, the sine is the opposite over the hypotenuse. Opposite is 4. The hypotenuse is 5. So 4 over 5 is the sine of angle y. The cosine is the adjacent over the hypotenuse. The adjacent side is 3. The hypotenuse is 5. The cosine is the adjacent over the hypotenuse. Fairly simple. Again, if you can keep this at the side of your table, on a sticky note, on a note card, everything like that would help tremendously. Okay? So far, so good. Let's do another one. Okay? This one says your turn. Pause the video, work it out, and see how you do. Good, you're back. Let's take a moment and take a peek at this. This is a triangle that we've looked at before. It was in our last lesson, and we found the tangent of angle A and angle B. This time, we're going to find the sine and the cosine of angle B. I'm going to write my SOHCAHTOA here. That's just what works for me. You got to find what works for you and use it. But you won't know that until you practice. So, let's look at angle A. This is always going to be our hypotenuse because it's across from the 90. Sometimes, hey, you know what? Sometimes you just maybe want to take the thing that is less work. Hypotenuse, opposite, adjacent. Good enough? Remember, it's always over the hypotenuse for the sine and the cosine. 39. 39. It's that easy. Opposite. 15. Adjacent. 36. Uh-oh. We have to simplify these. Divide by 5. We get 5 over 13. This one, divide by 3. You get 12 over 13. Did I say divide by 5? I really meant divide by 3. All right, let's take a look at angle B. If we're talking about angle B, blue B, get it? Just kidding, I totally didn't plan that. The opposite side is 36, while the adjacent side is 15. But the hypotenuse is always the hypotenuse. Since sine and cosine are all over hype, we're going to put the hypotenuse right on the bottom. The side that's opposite angle B is 36. Adjacent to B is 15. Don't forget to simplify. Divide by 3. You get 12 over 13 and 5 over 13. I want you to notice something very special that's happening. The sine of A is the same as the cosine of B. Vice versa. The sine of B is the same as the cosine of A. Weird. Cool pattern. Let's try some more. This question asks us to find the sine of S, the sine of R, the cosine of S, and the cosine of R. But I want you to find not just the sine and cosine of S, but also the tangent. Find the sine, cosine, and tangent of both angles S and R. So here I'm going to write my SOHCAHTOA. And it says to write the answer as a fraction and a decimal rounded to 4 places. All right, so we got our work cut out for us. This one is not going to be easy peasy lemon squeezy, but it's doable. Lucky for us, those numbers will not be able to be simplified. So let's start out with writing our ratios. The sine is the opposite over the hypotenuse, and we're talking about S. Okay? Angle S. Across from angle S, the opposite. Oh, I have a good idea. Let's write this. The opposite is 63. The one that's adjacent to angle S is 16. And the hypotenuse is 65. All right. Opposite over hypotenuse. Pause. Come back in a few when you're done. The cosine. 16 over 65. The tangent. Careful. 63 over 16. The sine of R. Let's take a look at side R and do the same thing as we did with angle S. So angle R, the opposite side to angle R is 16. The adjacent side is 63. And of course the hypotenuse is 65. So, toa. Opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. Remember what I said about the tangent ratios of the two acute angles? They're reciprocals of one another.